Welcome back to the Tiger Center at Lewis & Clark. Today we're going to be talking about Algebra 1 Plus, where the plus means we're in the Math Tutoring Center. We're trying to break algebra into small parts for better understanding. Today's topic will be Unit 7A, and we'll call this Practice 001. Our objective today: I can identify radical functions. Our parent function that we'll talk about today is y equals the square root of x. Well, let's draw a little table. Pick some arbitrary values for x, see the process, and then find our y value, creating 4 coordinate points that we can use to actually graph the parent function y equals the square root of x. The first value we'll pick will be 0. Anytime we see the variable x, we'll put a 0 in. Square root of 0? Well, the square root of 0 is 0 times 0, which gives us a coordinate point of x comma y, 0 comma 0. The second value will be 1. Square root of 1. What two numbers multiply together to get 1? Sure, 1. So our y value, the output, will be 1, creating a new coordinate point x comma y, or 1 comma 1. Our next value for x we'll pick is 4. Plug that in. Square root of 4. Two numbers that multiply together to get 4. 2. So our output will be 2, creating a coordinate point x comma y again of 4 comma 2. Lastly, we'll pick the number 9. It's also a perfect square. Square root of 9? Sure, 3 times 3. So it'll give us an output of 3, picking a new coordinate point of 9 comma 3. Let's take a second and actually graph these 4 coordinate points. 0 comma 0, 1 comma 1, 4 comma 2, and 9 comma 3. Now we can actually connect the 4 points and see that the parent function y equals the square root of x starts at the origin, 0, 0, goes up and to the right, off into infinity. From this, we're going to try to create a tool that we can use to help identify radical functions. Now, what we're going to write out here, it would be a good idea to try to get a 3x5 card. If you don't have one, make sure you see me tomorrow. We'll get you a 3x5 card. You can write out this and create your own tool that we'll be able to use over and over throughout this unit. We're going to write plus or minus a, plus or minus a big radical sign, or a square root sign, plus or minus x, plus or minus a. Try to use some colors here. First we're going to talk about plus or minus a. Plus or minus a. If it's a positive a, that moves the curve up a units. If it's a minus a, that moves the curve down a units. We'll box that off. Next thing we want to talk about, the plus or minus that's on the outside of the radical. Plus or minus on the outside. If it's a positive, that flips the curve up like the one we have. If it's a negative, it flips the curve down, like this. Box that in. Now we're going to move to the inside. Now the inside is the tricky part. First thing I'm going to do is look at the whole inside, the plus or minus x plus or minus a. We want to think of this as what makes this value 0. So we'll write down what makes the inside part 0. In other words, we're looking for the square root of 0. That will be our starting value for x, or the origin, the starting point. So in this case, we would have x plus or minus a. Well, look back at our parent function when we started today, the square root of x. What makes that 0? Sure, x equals 0, which was the origin today. So the first thing we'll look at is what makes the inside part 0, square root of 0. That value of x is the starting point. Again, square that off. And the last thing we need to look at will be plus or minus the x on the inside. This, if it's a positive, it flips to the right, like the parent function that we have today. If it's a negative x, it flips to the left, like that. So now we have a tool that we'll be able to use the rest of this unit to help identify radical functions. Use this as your entry task for the day to help you solve the work problems under practice 001. See you tomorrow.